Hey everybody. So video 3, we're going to kind of dive a little deeper into rational expressions. Not only are we going to simplify them and state our NPVs, now we're going to do some sort of mathematical operation with them. So that would be multiplying, dividing, adding, and subtracting. Okay, so those steps in the last video that I talked about where we need to simplify, we need to factor, then we need to state your NPVs, then we need to simplify those 3 steps. Those are still going to be the same 3 steps. We're now just adding after that. Okay, now do whatever you need to do to add or do whatever you need to do to subtract. And so to do that, because we're dealing with fractions, we need to kind of review as well how you just add fractions together, add or multiply fractions together, divide fractions together, or subtract fractions, okay? So first thing we're going to do here is just kind of review some of those things. Operation with rational functions includes adding, subtracting, multiplying, and dividing. No matter what the question, the standard procedure is to start with factoring and stating your NPVs. To multiply fractions, you multiply the tops together and then multiply the bottoms together, okay? This essentially means that means that your factored form gets put together as one big fraction, okay? So then any factor that's on the top will divide out with any factor that's on the bottom, if they're the same, okay? Okay, to divide fractions, you would change the division to multiplication and then flip the second fraction, okay? And I'm gonna show you examples of this as we go. Dividing by 2 produces the same result as multiplying by 1/2. To add or subtract fractions, you need a common denominator. Once you have this, you just add or subtract the numerators, okay? Be careful to distribute the negative when subtracting fractions that have more than one term on top. Now that's gonna appear in a few questions, but if you had something like this, minus x plus 5 over x minus 7, okay? You need to realize that that actually says minus x minus 5. That subtraction sign gets put on both of those terms. And that often comes up in these questions. It's something you want to be super careful about, okay? All right, so we're just going to practice multiplying first. Let's look at that 2 over 3 times 5 over 7. I'm multiplying the tops, multiplying the bottoms. That's going to give me 10 over 21, okay? Nothing strenuous there. I'm already in reduced form, so everything's good. Now, the 17 over 24 times 3 over 34, you could just multiply 17 times 3 and 24 by 34, and then take those answers and reduce, okay? That's totally fine. I just want to approach this a little differently than that, only because it's going to help us see the process when we are talking about polynomials in just a second. Okay, so what I want to do is I want to look at factors instead. I want to call that 24 on the bottom here. I want to call that 2 times 12, or maybe I even want to call it 3 times 8. Now, why would I decide between those two things? 3 times 8, calling that 3 times 8 is actually better than calling it 2 times 12. Can you take a guess as to why? My why is because there's a 3 up here. So if I call this guy 3 times 8, I have a 3 on the top, I have a 3 on the bottom, and they'll be able to divide each other out. Okay, the 34, I can call that 2 by 17. So now it's like I've created this in factored form, okay? And so I can look at this and say anything on the top will divide out with anything on the bottom. So my 3's divide each other out, and my 17's divide each other out. And I'm left with, well, I've got 16 on the bottom, and what do I have on the top? Remember, the top doesn't disappear, even if all the numbers disappear, I'd be left with a 1 on the top, okay? So I end up with 1 over 16, okay? So now, let's try that a little messier. We're gonna try that with some polynomials here. So, first step, factor. So take a look at each of these 4 little sections, kind of the top left, the bottom left, the top right, and the bottom right. And we're gonna try and factor them. So the very first guy here, I can take out a 7x squared. And that's going to leave me with x plus 2. On the bottom, I'm looking for 2 numbers that multiply together to give me 15, add together to give me 8. That would be 3 and 5. So I'm looking at x plus 3 and x plus 5. Let's go top right. Looking for 2 numbers that multiply together to give me -3 and add together to give me 2. That would be 3 and -1. And then on the bottom there, I can take out a 14. That would leave me with x plus 2. So this was step 1 of all of those same steps, right? Step 1 is factor. Step 2, state your NPVs. Step 3, do any simplification you can. And now then do the math that you can, okay? For step 4, that's kind of the new step 4. So I have it all in factored form. Now I want to state my NPVs. So x can't be -3, x can't be -5, and x can't be -2. Remember, I don't care about anything on the top. So -5, -3, and -2. Now I can start looking at dividing stuff out. Anything on the top would divide with anything on the bottom. It doesn't have to be in the same fraction as long as it's multiplication, okay? So x plus 2 will divide with x plus 2. X plus 3 would divide with x plus 3. And that looks like that's everything I can do. So then I can just combine what's left as one fraction, okay? So I'd have x squared. Oh, sorry, I forgot to say, let me go back there. The 7 divided by 14 would be 1/2. That's where that 2 comes from, okay? So on the top, I'm left with x squared times x minus 1. And on the bottom, I've got 2 times x plus 5, okay? All right, try this guy. Again, first step, we just got to factor it all, okay? So pause me and try that. So on the top here, you see a difference of squares. That's going to be x plus 3, x minus 3. On the bottom, you're looking for two numbers that multiply together to give you -21, add together to give you -4. That'd be -7 and 3. Up here, we're gonna take out a 5x, and that's going to leave us with x minus 7. And then on the bottom corner there, we can take out a 2x squared, and that's going to leave us with 3 minus 2x. Okay, that was step 1. Step 2, we're going to state our NPVs. X can't be 7, x can't be -3. Don't forget this guy. Kids often forget this guy because there's no plus or minus attached to it. X can't be 0 for that guy. And then over here, if you're unsure of that guy, set it equal to 0 and solve. So 3 minus 2x equals 0 like this. Bring your 2x over, divide by 2. So x can't equal 3/2 there, okay? Notice I am also writing these in order from smallest to largest, okay? All right, now I can do some canceling or dividing out, however you like to say that. My x minus 7s can go, my x plus 3s can go, and that looks like that's it. So I'm gonna have 5x times x minus 3 on the top, and then 2x squared times 3 minus 2x on the bottom, okay? Okay, the simplified product, remember product is just the answer to a multiplication sentence. The simplified product of 2n to the 4p over 3m times 6 m to the 6 over 3n squared p squared can be represented by, I've got a times n to the b, m to the c, all over 3p there, where a, b, and c represent single digit numbers. In the simplified product, what's a, what's b, and what's c, essentially, okay? So we just need to take this and actually multiply it out, okay? So multiply the tops, multiply the bottoms. I've got, 2 times 6 there, so that's 12. I've got n to the 4. Let's do an alphabetical order. So m, 6, n to the 4, and p, all over 3 times 3 is 9. And then I've got an m, I've got an n squared, and a p squared. Okay, so now what I want to do, 12 over 9 would reduce to 4 over 3. And that makes me start feeling good about life because you'll notice that there's a 3 in my answer right there. Okay, m to the 6 over m is going to give me m to the 5. When you're dividing powers of the same base, you subtract the exponents. N to the 4 over n squared is going to give me n squared. And then P divided by P squared will give me P to the -1. So that means there's a P on the bottom, okay? Which is awesome again, because that's exactly what that bottom there is, right? So that tells me A is gonna be 4. Oh, I should have paid attention to the order that the question was in. Sorry, N actually went first there. So B is going to be 2. Just be careful of that. Make sure you are connecting exactly the way the question looks with what your answer looks like, okay? So N is going to be 2. Sorry, the B value is going to be 2, the number that goes with N. And then C is the number that goes with M, and that would be 5, okay? So we end up with 425. Okay. All right, let's try division. So division, very similar to multiplication. You just have to change it to multiplication and flip that second fraction. So when you see 2/3 divided by 5/7, the first thing I want you to think of is rewriting that as a multiplication statement. So that'll be 2/3 times 7/5. Then you can just multiply the tops, multiply the bottoms. So you've got 14/15. Okay. The 24/17 divided by 3/34. Again, we're going to flip it. So that's 14/17 times 34/3. Again, I'm going to write this in more of a factored form so I can see the factors a little bit better. Sorry, that's a typo here where you see that 14. That should be 24. Okay. Just a little typo there. So then I broke my 24 into 3 times 8, and I broke my 34 into 2 times 7. With those factors, I can see that my 3's will divide out and my 17's will divide out, okay? Because everything's multiplication here, okay? I can only start canceling out like that when everything's multiplication. And so then I'm left with 8 times 2, which would be 16, okay? I'm just gonna take that ink off here before I keep going. Cool. Okay, so now we're going to try that. It's just going to be a little messier because we're going to have polynomials to start with, and we have to do all that factoring process to start with, okay? So take a look at this. First thing we want to do is factor it. So pause me and you do that first. So on the top, I've got a difference of squares, x plus 1, x minus 1. The bottom, I'm looking for two numbers that multiply together to give me 14 and add together to give me -9. That's going to be -2 and -7. Top right there, two numbers that multiply together to give me -5 and add together to give me 4. So that would be 5 and -1. And then the bottom, two numbers that multiply together to give me -35, add together to give me -2. That would be -7 and +5. Okay, so here is my factored form. That is step 1, just factor everything, okay? Now, I need to state my NPVs, and when I go to state my NPVs, I have to remember that I'm about to flip things. So when I look for NPVs, this all now becomes important to me, okay? Because on this fraction here, I'm about to flip it. So that top part you see is about to become a bottom part, okay? So x can't equal 7, x can't equal 2, x can't equal 7. I don't need to state that twice. It's already stated. X can't equal -5. X can't equal 1. And I've already stated that x can't equal -5. Okay. So I got my NPVs listed. Now I'm going to rewrite it as multiplication, and then I can start dividing things out. Okay. I would always encourage you to rewrite it as a multiplication sentence first, then start dividing everything out. Okay, so now I can see that my x minus 7s will go, my x plus 5s go, and my x minus 1s go. And so I'm left with x plus 1 divided by x minus 2. Okay, x plus 1 divided by x minus 2. Okay, so now on this guy, same sort of setup, but now we have a combination going on here. I've got a division and a multiplication. It gets messier, but you're still doing the exact same thing. So the first thing we want to do is factor everything. So pause me and you go factor everything. So on the top far left there, we've got 3x, and then that'll be x minus 2. On the bottom, this is going to be x plus 1, x plus 3. Two numbers that multiply together to give you 6 and add together to give you -5. So that's going to be x minus 2, x minus 3. This guy here, will be x minus 7, x plus 1. Here's a difference of squares. Remember I said in an earlier video, that's often missed by kids. Watch for those difference of squares. That'll be x plus 3, x minus 3. And then down here, I've got what? I can take out 9x squared, okay? And then that would leave me with the 7 minus x. Okay, so that was step 1. Everything's in factored form. Next thing to do is to state your NPVs. Now, again, because of that division sign, when we have NPVs, we're going to be looking for all of this, okay? I don't care about the top here because it's not being flipped, and I don't care about the top over there because it's not being flipped, but I do care about the top here. So x can't equal -1, x can't equal -3, x can't equal 7. I already took care of that guy. I already took care of that guy. Here, don't forget him, x can't equal 0, and then up top here, x can't equal 2 and 3. Okay, so when I list all of those, we've got -3, -1, 0, 2, 3, 7. So remember, it's just a good practice to list them in order from smallest to largest. Okay, now the next thing I'm going to do is I'm going to rewrite this so that it's all multiplication. So I don't flip every fraction, I only flip the fraction that's to the right of the division sign. Okay, so that's just the middle fraction here. Now I've written everything as division and I can start canceling things out. The next thing I want to talk about here is this guy with this guy. Do you remember me talking about this in another video for rational expressions? Those are the exact opposite of each other, right? I have a positive x and a -7. And then on the bottom there, I have a positive 7 and a -x. They will divide out, but they will create a -1. Okay, so I'm going to account for that right away right now just by putting a negative right there. Okay, and I've taken care of those guys. Now, the rest is easier. My x plus 1s will go, my x minus 3s will go, my x plus 3s will go, my x minus 2s will go. I always call that my therapeutic canceling. It feels really good to cross all of that stuff out. So I'm left with -3x over 9x squared right now, but then that will reduce. 3 over 9 will reduce to 1 over 3, and x over x squared will reduce to just an x on the bottom. Okay. So final answer ends up being -1 over 3x. Okay. Awesome. All right, so now let's talk about addition and subtraction. With addition and subtraction, we need a common denominator. So if you look at this first guy, 2/3 plus 5 over 7, the easiest way to get a common denominator is just to multiply your two factors together, okay? Sometimes you can get a smaller one, and that makes your life easier. But if you don't see a smaller one, it will always work by multiplying the two factors on the bottom together. So that means my common denominator here is 21. So I ask myself, well, how did I go from a 3 to a 21? I multiplied by 7. So whatever I do to the bottom, I have to do to the top as well. So that 2 also gets multiplied by 7, and that would become 14. Okay, how do I go from a 7 to a 21? I multiply by 3. So whatever I do to the bottom, I have to do to the top as well. So 5 times 3, that will become 15. Okay, so I've written equivalent fractions. And once I've written equivalent fractions, I can just keep it as one big fraction with the common denominator. But that's where that 14 and 15 came from. And now I just add the numerators together and I get 29 over 21. Okay, let's look at division. Division is the same thing. I need a common denominator, but look, I want to think about this in factored form again first, okay? Because I'm about to take you to polynomials, doing this with polynomials, and it's kind of the same setup, right? So what I want you to think about is I want you to think about that 34 as 2 times 17. Now, if I want a common denominator here, I just need one of every factor that I see. So I need a 2 and I need a 17. I don't need a 17 twice. Okay, 17 is already common to both of those fractions. That's kind of the point I'm trying to make here. That's what I want you to see. Okay, there's no point in putting the 17 down twice. It's just already common to both. Okay, so really, in order to accomplish this, all that's missing is I need a 2 on this guy. You see that? So if I put a 2 on that guy, I need to put a 2 on this guy as well, because whatever I do to the bottom, I have to do to the top. Okay, so that's going to look like that. And then that gives me a common denominator of 34 on the bottom. And then on the top, I end up with 48 minus 3, which is 45. Okay, so now we're going to practice doing that with polynomials. Okay, so here's the first one. Again, just like every other rational expression I have given you, we got to factor. Okay, every polynomial you see there should be factored. So x minus 7, there's nothing I can do there, but x squared minus 49, that's a difference of squares. So I'll write that as x plus 7 and x minus 7. Okay, so now what do I need for, oh, sorry, I got ahead of myself. After we factor, we need to state the NPV. So x can't be plus or minus 7. Okay. Now we're ready to go with a common denominator. So this guy has x minus 7 and x plus 7. This guy only has the x minus 7, so I need the x plus 7 to go with him. Okay, so I'm going to put an x plus 7 on the top and on the bottom, and then I have a common denominator. Okay, so once I have a common denominator, I can write it as one fraction, and I'm just going to subtract my numerators. That 3 needs to get distributed to both terms into the x plus 7. So that's going to be 3x plus 21, and then minus 4, okay? And then 21 minus 4, I can do, and that's gonna give me 17. So 3x plus 17. All over x minus 7 and x plus 7. I should have said that as well, okay? Good. Okay, next guy, same setup. First thing I wanna do is factor everything I see. So pause me and do that yourself. Okay, so I end up with the bottom left there is x plus 3, x minus 3. On the top right, I have an x that I can take out, so that'll be x times 4x plus 1. And then on the bottom right, didn't know my left and right there for a sec, sorry, sorry, I paused there for a second because I realized my placement of this. You guys probably don't see the question. You probably see me. I'm hiding the question, but you have the question in your book. So sorry, that was my hesitation there. I was just thinking I can take myself away for a sec so you can see the question that I'm looking at. But you do have it in your book, so I don't think that'll be a big deal. So then on the bottom there, I can take out an x, and then I'd be left with x minus 3. Okay, so in factored form, this is what I'm looking at right now. Okay, now I need to state my NPVs. So x can't be plus or minus 3, and x can't be 0. Okay, now I'm going to make my life a little easier. I can simplify before I start doing the math. These x's will divide each other out, okay, because they're on the same fraction. If there was an x over here, I couldn't divide that x with that x, okay? That wouldn't work because there's an addition sign in between. But if they're on the same fraction, I definitely can simplify things on the same fraction, okay? Okay, so they're gone. I have an x minus 3 here. On here, I have an x plus 3 and an x minus 3. So that tells me I need an x plus 3 on the right side. So I'm going to add in an x plus 3 to the bottom and to the top of the right side. Now I have a common denominator, but I have to clean up the numerator. So this is going to get FOILed, right? 4x times x, 4x times 3, 1 times x, 1 times 3. Clean all that up, and then I have everything on one numerator. So I've got the 9 plus 4x squared plus 12x plus x plus 3. That was just me foiling. Okay, now the 9 and 3 can come together to be 12. The 12x and x can come together to be 13x. So I'm left with 4x squared plus 13x plus 12 all over x plus 3, x minus 3. You would want to leave the denominator in factored form. Okay. You could try to factor the numerator. You often can't factor the numerator in your answer. There's the odd time that you can factor it and you'll be able to cancel one more binomial out. But often we just leave the denominator in factored form and the numerator can be either in simplified form or factored form, okay? Okay, let me just take that ink off for you. So again, I'll just hide myself for a quick sec so you can see the question I'm on. X squared plus 5x over 7 minus x squared minus 7x over x squared minus 4x minus 21. You're going to factor all that for me. Okay, and so the factored form that you should have gotten is x times x plus 5, x times 7 minus x. And then on the other guy, it'd be x plus 3, x minus 7 on the bottom. Okay, so now a couple things we can do. The x's will divide out. And then I want you to notice again, I've got this 7 minus x versus an x minus 7. Those are not different denominators. All we have to do is we have to factor a -1 out of one of them, and then they'd be the same denominator. That way, I just need to have my denominator be x minus 7 and x plus 3. Okay, so I chose to, oh, sorry, I forgot to talk about my NBVs. How silly of me. Okay, so x can't be 0. I just get so excited to do the question. X can't be 7, x can't be -3. This one also says x can't be 7. By the way, that's also a reminder that they seem to be connected. When you end up that they give you the same NPV, that's a way to know you're just going to factor out a -1 and you can write them the same way. Okay. All right, so I chose to factor out the -1 from this guy here. That's why this negative shows up right here. That way I could write that as x minus 7. The other thing I did in this step was I needed the x plus 3 on this front fraction. So I put an x plus 3 on the bottom and an x plus 3 on the top. And you can see that I've also canceled out those x's. They've divided out and they're not there anymore. Okay, so on the top, I have to FOIL this out. So this will be x squared. This will be 3x, 5x, and 15, and then minus 7x. Okay, my 5x and my 3x just added up to be 8x there. Now I need to distribute that negative sign. So that negative sign will apply to everything here. And then I'll combine like terms as well. Okay, so when I do that, your final answer there will end up being negative x squared, negative 15x, that comes from the negative 8x plus negative 7x. That's where that negative 15 comes from. And then minus 15 there. Okay, awesome. Okay, sorry, let me get that ink off for you. When the expression 2x over x plus 5 minus 3x minus 2 over 2 times x plus 5 is simplified to a single rational expression, the result is. So again, here I go trying to get a common denominator. I already have a 2 and an x plus 5 on this guy. I have the x plus 5 here, but I don't have the 2. So essentially, I just need to put a 2 on the top and on the bottom there. Okay, so then when I do that, I get a common denominator, and this ends up being 4x. Now, I warned you about this at the beginning of our time together here. This negative, be careful of this. This will be minus 3x and plus 2, okay? And I can guarantee you, if you forget that, the wrong answer, that is the result of you forgetting that, is sitting in one of these distractors, okay? So you got to be super, super careful with that. Okay, so that's going to give me 4x and then minus 3x and plus 2, and then 4x minus 3x is just x. Okay, so that is B for an answer. Okay, for some whole number k, the simplified form of x minus k all over 4x plus x plus 1 all over 2x is 3x minus 5 over 4k, determine the value of k. Now, that can feel, you read that and you're like, whoa, this is really, really complicated. Just start unpacking it bit by bit, okay? Think about the things that you know. You know, in order to have, you know, your common denominator, first of all, has to be 4x, right? And so in order to get a 4x, this second fraction here, you're gonna have to multiply by 2 over 2, okay? So let's just set that up. I know that x can't be 0 because I have x on the bottom, so that's an NPV. And I know I have a common denominator of 2. Okay, sorry, I know I need the 2. That I didn't say that right. I know I need the 2 on the top and the bottom to get that common denominator of 4x. Okay, so now that 2 is going to get distributed to the x and to the 1. Okay, so that's going to end up being x minus k plus 2x plus 2. X plus 2x is 3x, so that now becomes 3x minus k and plus 2. Now, take a look at this. This said 3x minus 5. Now it says 3x minus k plus 2. Well, that tells me negative k plus 2 has to equal negative 5. Okay, so I'm just going to set up that little equation and solve for k. So if negative k plus 2 has to equal 5, I can subtract 2 from both sides and then say that k has to be 7. Okay, because that would give me negative k equals negative 7, and then k has to be 7. Okay, so this was a review of adding, subtracting, multiplying, and dividing, lovingly referred to as mathematical operations in rational expressions, okay? The next thing we need to do is equations, and so I will see you on the flip side, as they say, for that video, okay? Take care.